have this. Okay. So chapter 1, the important things to know are basically the relative size of things. So for example, how big is the solar system compared to a galaxy? What's bigger, galaxy clusters or galaxies, that kind of stuff. So know about just the rough size and scales of things in the universe. Know about powers and tens, scientific notation. So if I give you a number, you can convert to scientific notation and vice versa. So basic stuff like that from first week. Know the basics of Kepler's laws, right? So, planets follow, orbits, period and distance are related, that kind of thing. Know Newton's law of gravity, which says that force changes with mass and distance. So just know how to work some basic problems on that. They don't put anything too tough with that. And then fundamental forces, we didn't cover that in detail, so I'd say don't worry about fundamental forces. Just know, it's gravity, light, strong nuclear force, and weak nuclear force. That's it. Okay. There's a fair amount on the test about light because light's so important. So just know the spectrum, the different wave bands, radio through gamma rays. Know that energy and frequency go together. So higher frequency light has more energy. So gamma rays have more energy than, say, blue light, which has more energy than red light, which has more energy than radio waves. So the frequency of the light determines the amount of energy that it has. Objects emit light, this next line here, because they're at a certain temperature. So everything that has a temperature emits light. And the kind of light that gets emitted depends on temperature. So as something gets hotter, the light that emits gets bluer and brighter. So as you heat up a piece of metal, it'll start to glow red, then orange, then yellow, and eventually if you could heat up enough, it would glow blue hot. Same thing with stars, right? So red stars are cool, blue stars are hot. That's the basic thing there. And the way the light is perceived by this object is what's called a continuous spectrum. So an object at a certain temperature emits light at all different wavelengths, but the peak wavelength depends on temperature. So for example, the sun is a medium hot star. So it emits, red through violet, but the peak of the sun's emission is in the yellow part of the spectrum. Right? It's a yellow star. So a red star would be cooler than the sun, a blue star would be hotter. Okay. Inverse square law, the brightness of stars changes with distance. So if a star is twice as far away, it emits 1 over that distance squared as much light, or a quarter as much light. So something twice as far emits a quarter as much light. So same as gravity. So if you know the law for gravity, you know the law for light too. Okay, phases of matter, just know that as things heat up, they go from solid to liquid to gas, and then finally the hottest phase of matter is plasma, right? And so sun and stars are made out of plasma. They're too hot for a gas, too hot for a liquid, too hot for solids. Okay? A little toddler running around. Sorry about that. Okay, related to that, let me come back to telescopes. Spectra are really important because they tell us what the universe is made out of. So you have 3 types of spectra. You have continuum, which is caused by an object at a certain temperature. You have emission spectra, which is a hot, thin cloud of gas. So as the gas gets heated up, it emits light at certain wavelengths, which depends on the elements that make up that gas. And that's like the fingerprint for those elements. So if you see the spectrum for a cloud and you see lines at certain wavelengths, you know there's hydrogen there. Other wavelengths, it might be nitrogen or something else. Okay. Absorption spectra are produced when light from a hot, dense source, say a star, passes through a cool, thin gas, and certain wavelengths are absorbed. So you see a rainbow spectrum, what we call a continuous spectrum, with dark lines taken out. Those lines are wavelengths where those elements absorb that type of light. So you can tell what a cloud's made of both by the lines that it emits when it gets hot, which is the emission spectrum, or the lines that it absorbs when a rainbow passes through it, which is an absorption spectrum. Either way, it tells you what the cloud's made out of. Okay. Any questions about that? So just know 3 different types of spectra, what they look like, and why they're important. Continuous spectrum is also called a black body spectrum, and just know that the peak wavelength of that emission depends on temperature. Okay. So hotter stars emit more light and bluer light. Atoms and energy levels. You don't need to know too much about this, but just know that every atom has its unique fingerprint in terms of the types of light that it emits, and that depends on the energy levels inside the atom. So hydrogen spectrum is different than helium, different than lithium, different than beryllium, different than iron. Every element has its unique signature, and so we can tell what stars, galaxies, clouds across the universe are made out of based on the light that they emit and the spectrum that we receive. Okay. Spectra are also important because they tell us the Doppler shift. So the Doppler shift is the change in the spectrum's wavelength caused by the motion of the object. So if something's coming towards us, the spectrum for the object will be shifted towards blue wavelengths. If it's coming away from us, it'll be shifted towards red wavelengths. You can measure the amount of that shift, and that determines the velocity of the object. You can tell that the Andromeda Galaxy is coming towards us at 1,000,000 miles an hour based on the spectra of the galaxy. Right, so it tells us the direction that's going towards or away from us, and it tells us velocity. So Doppler shift's really important because it tells us velocity and direction. Spectra are important because they tell us composition, what things are made out of. Okay. Ignore this next part about star properties. We'll be talking about that this week, but it's not on this test. Okay. Coming back to telescopes. Just the basics about telescopes. No, there's two basic types. There's reflecting telescopes, which use a mirror to focus light, and there's refracting telescopes, which use lenses. Most large observatories use reflecting telescopes because it's easier to build a big mirror than a big lens. And so the largest telescopes on Earth are now 10 to 12 meters across, which is 30 or 40 feet across for the main mirror. That's huge. And astronomers want bigger light, bigger telescopes because it collects more light. Right. So just like having a large bucket to collect rainwater, the bigger the bucket, the more rain you collect, the bigger the telescope mirror, the more light you collect. And to answer the second question, the light gathering power of a telescope depends on its area, right, which goes as pi times the radius of the mirror squared. So if you double the diameter of the telescope, it collects 4 times as much light. Okay. And then just to finish up with that, telescopes are described by the size of their main mirror. So if you say you're using 8-inch telescope, that means the mirror or lens of that telescope is 8 inches across. Okay. And that's it. I mean, just think about, what are the most important topics for each of these different categories. Write some good notes. You have your book with you too. And then, you should be fine on the test. Okay. Any places people are fuzzy or want more detail or aren't quite sure about?
No, pretty much everything was on the quizzes.
Yeah, I think the quizzes are actually a pretty good study guide for the test. So, I'd say some people print out the quizzes so they have them with them.
I do though.
Yeah, that's a good idea. That's a good way to study for the exams. But I don't throw any curveballs. It's fairly straightforward. Some people have, a hard time with this stuff because it's like physics, and it's been a while since they've taken physics. But, once you practice with it, take the quizzes, write your notes over again, spend some time studying it, it'll start to make sense. It's a lot of information, I realize, especially since it's new. But, do the best you can. It's important that we know this stuff, so then when we talk about stars and galaxies and black holes and stuff like that, why we know what we know about them. How do we figure that out? How do they know the mass of a black hole? Well, they can measure the spectrum of the accretion disk around it. Right? How do we know what the Andromeda Galaxy is made out of? Based on its spectra. Right? So I want you to know, how and why we know what we know about the universe. So that's why these first few chapters are important. Okay? And then this next week we talk about properties of stars. How do we determine radius, mass, temperature, all these different properties. Really interesting stuff too. So we apply what we learned the first couple weeks in this next week's worth of work too. Okay?
No.
Great. Any other questions?
No, from my end.
Is the test like all multiple choice, fill in the blank, or?
Yeah, it's multiple choice, short answer, fill in the blank, that kind of thing. Image analysis, right? Click on this area of the image, that kind of thing. Pretty straightforward, right? So not too bad. Any other questions?